Hi, welcome to video 39. This video, guys, is all about record structures, and we're looking specifically at records and Python dictionaries. So the purpose of this video is to know about the traditional record data structure offered by some programming languages, and to understand the basic use of the Python dictionary data structure as an option for managing records. So guys, you need to be aware of records for your GCSE theory, but the Python dictionary is not a data structure that you are required to know for your GCSE exams. Okay. Having said that, the Python dictionary is a very good example of a data structure that you could use for your practical programming project, and it's also a data structure which is mentioned in a variety of textbooks and also on the internet for GCSE guidance as well. So we would be wise to address both traditional record structures, guys, and the Python dictionary as well. So with that in mind, let's have a look at the spec specifically. So with GCSE Computer Science, the scope of what you need to know when it comes to records has always been a little bit woolly. You can see that it's vaguely mentioned on the left hand side there, but it doesn't say specifically to databases, and that is one of the reasons why some OCR GCSE textbooks specifically mention the record data structure and others don't. And it's also one of the reasons why, if you go on to BBC Bite Size, they do in fact talk about the record data structure as well as databases themselves. So it would be sensible for us to cover it off, guys, to make sure that you have addressed this as something which might pop up in your exam. Okay, so let's talk about records in tabular structures, guys. So we're talking about spreadsheets and the tables that you would find in a database, which typically look like this. So the picture you can see on the slide, let's assume that this could either be a spreadsheet or it could be a picture of a table in a database, because they're both very, very similar, and of course they both organize data in rows and columns. When it's a database table, of course, we tend to talk about fields and records, but you get the gist, guys. Okay, it's a tabular way of structuring data, and each of the individual rows or records in the table or the spreadsheet is significant as a specific instance of data stored that describes, for example, a customer, or it could be a student, or whatever the context happens to be. So we can say that records from a database table or a spreadsheet often comprise different data types, and the record type data structure mimics the style of individual records, including the use of unique identifiers or keys for each record. So what does that actually mean? Well, one of the techniques that we can use for working with tabular data outside our program is we could import a table from a database, or we could import a spreadsheet as a text file. We can do a text file exports from either of those two formats, and then we can work with it by reading in that data from the text file. The problem, however, guys, is that in a database table and also in a spreadsheet, and you can see this on the slide, we very often store individual items of data as a specific data type. So you can see here with customer ID, that could be an integer. The key account is likely to be a Boolean data type. First name and last name are likely to be strings, as is email. Phone is likely to be a string as well, but we could have stored age as an integer data type along with the customer ID. When we read that or export it into an external text file, we lose all of the original data types. So that means that if we read a text file into Python, we then have to cast individual items of a record back into their original data type. So that's not ideal, really. So in order to address this, and of course the fact that the array data structure will not cater for multiple data types, many programming languages evolved a particular type of data structure to cater for the records which might be imported from other applications, or a record which you might want to create within your own code, but of course wanting to use different data types. So let's look at an example of a very traditional, very famous couple of programming languages that have created the record data structure as a built-in feature of those languages. And Delphi, an example of which you're looking at on the slide now, and also Pascal are two programming languages which developed this requirement a long time ago. So let's have a look at how Delphi goes about creating and using what it calls the record data structure. Actually guys, before we do that, I'd like to pop back to our tabular data, our data in table form here from the previous slide. So let's imagine that the picture that you've got on this slide is a screenshot of a table from a database. So what's the typical terminology that we apply to a table in a database, guys? What do we call, for example, these individual columns? Well, in a database language, the column of a table is called a field. So each one of these is a field. We have the email field, the phone number field, the age field, and we have, of course, data which is consistent in each of those fields. So the age field contains the age information about each customer, and likewise, guys, the email field will only contain the email address of each of our customers. Okay, so let's also put a box around here as well, so we've got two to work with. All right, so in database terminology we call these fields, but when we're talking about record data structures in programming languages, we use a slightly different terminology. So instead of using the word field, I'm going to use the word key. Okay, so I'm going to put key up there, and the individual items of data in each of those fields is called a value. All right, so what we'll say here is, if I can pop in a text item which sort of you can see, all right, each of these excuse me, each of these guys is called a value. Okay, so let's swap terminology for a moment. Let's swap the terminology of the field in a database table and call that the key. All right, so we would say that the email is an example of a key, and phone is an example of a key, and age is an example of a key too. And within each of those keys we have sets of values which specifically relates to that key. Okay, so if we took the key called first name here, then each of the first names in that key are values associated with that key. All right, so hold on to the idea, guys, of keys, and for each key there is a set of values which are unique for an individual customer. Okay, so let's get rid of those boxes and let's go back and have a chat about Delphi. Okay, so guys, what you can see on the screen then is a typical example of setting up a record data structure in Delphi. So let's start at the top and work our way down. You can see first of all, guys, that the programmer, by virtue of the way that they've laid out their code and used really sensible names for variables, right, you can see what a difference this makes, because even though you may never have seen Delphi or indeed Pascal, which is very, very similar, you can sort of tell straight away what's happening here. All right, so what we've got is we have got at the top we have the term type. So this is basically telling Delphi that the next block of code is going to be about creating a particular type of data structure, and that type is confirmed here. All right, so we're telling Delphi that we want to create a record type, and the record will be a record data structure. All right, so the name of the record data structure is here, and it's called tCustomer. Okay, so that is the name that we've applied to this particular type of record data structure in the program. All right, now within the data structure, all right, we have these individual items, guys. We've got first name, last name, address, a couple of addresses, and then we've got city and postcode. So if you think back to what I was mentioning on the previous slide, we could say that each one of these would otherwise be, okay, the field in a table, and of course we're calling these keys now. So each one of these items, first name, last name, addresses, they are all individual keys, all right, and associated with our individual keys, okay, or in other words within the field of our table, then we will have data. And it is the case, guys, with Delphi that you have to be specific about the data type. All right, so we don't have to do that in Python, but here you can see within the confines of Delphi we have to specify, okay, that the value within each of these fields or keys has to be of a particular data type. Okay, and you can see at the bottom, guys, here we have created a couple of variables, John and Sarah, of type tCustomer. All right, so that, in other words, these are the variable names that we are giving to individual instances of our record data structure. So obviously you can tell that we are going to populate one of these record data structures with information about John, and then another one we're going to populate with information about Sarah. And you can see that John's has been populated in the next block of code below. All right, so we've said with the data structure that we specifically called John, all right, which we have structured to look like this, guys, at the top. Alright, we're actually going to put in some specific values now, and the specific values are here, guys. Okay, so these are the individual items of data that we would put in our table in the relevant fields. Alright, but using record structure terminology, guys. Alright, each of these keys, alright, has a specific value associated with it. Okay, so first name has been given a value of John. The key called last name has been given a value of Smith, etc., etc., guys. Okay, so I'm just trying to explain the data structure and how it works, and also the fact that the terminology that we're using here is keys instead of the fields of a database table, and we are talking about items of data as values associated with that key. All right, so let's have a look at another example, because this one, guys, although I mentioned earlier on that you could have different data types within a record structure, this one's not a very good example because all of these are strings. So let's have another look at Delphi, where the programmer has created a record data structure of different data types. Okay, now at the top, guys, there's some jiggery pokery going on where the structure of the record is being sort of created on the fly. So I'm going to ignore that because I don't want to get into the world of Delphi in too much detail, but you can see how it's worked here, guys. Okay, we have given a name to one of our data structure records called banana, and obviously, guys, this particular record is describing the banana uniquely. So you can see here that banana.name, all right, has a data type which is obviously a string. All right, so that, guys, would be a field within our database table, but obviously we're calling these keys within our record structure. Okay, isRound is obviously a boolean, guys. You can see it's been given an initial value of false, and these two data types underneath, guys, we would recognize those as float data types, okay, because they're decimal numbers. All right, now, guys, once we've created a name for an individual record, of course we can access it by virtue of its name. So we're looking for the record which has been given the name fruit, and we're asking the question, in the fruit record, okay, is the field or key of isRound, is that true or false? And if it's true, all right, then we're printing out a particular message to the user, and if it's false, then we're printing out another message to the user. Okay, so again, I won't go into that in too much detail because the key thing I wanted to show you is what a generic record structure looks like in other programming languages, and in fact in Pascal it's a very, very similar type of setup and use of the record data structure. Right, guys, so you may be asking a very pertinent question at this point in time, which looks a little bit like this, I suspect. Okay, if it's all about creating records of different data types, then why not just use a Python list? All right, after all, the Python list can store any data type. Okay, so why can't we use that? Well, the short answer is basically you can, and if you wanted to, even with your practical programming assignments, you could stick with the list data type, but I would very much encourage you to explore the world of the Python dictionary. All right, because it is very, very efficient and specifically set up to store data which originated as a record in a table of some type or other, guys. Okay, now Python dictionaries work very differently, and they store data more efficiently than Python lists. Python dictionaries do not use indexing, guys. Okay, they have replaced the idea of an index position like position 0, 1, 2, etc. with the idea of a key. So instead of using an index value to locate data in which would be a column, we are actually using the name of the field as our key instead of the index value. And what that basically means is that Python does not then have to store the individual fields in order. It can store them wherever it wants to, and it, instead of using index values which are sequential, it stores the data anywhere and uses a special type of computer science called the hash algorithm to both store and find individual fields within a record, and that makes it much more faster and much more effective when we have larger amounts of data. Okay, so they are a very, very good data structure to use, guys, and they take away some of the disadvantages that you have with Python lists. So I would encourage you to explore them, even though you may decide not to use them specifically. Right, guys, okay, so before we move on then, excuse me, Before we move on, obviously the Python monster resources are there on Schoology if you wish to use them. You have the booklets, the videos, and you have catalogue views, guys, which give you information about which of the many videos you might want to focus on for your learning, but also for your revision as well. Okay, guys, let's crack on and do some examples of Python dictionaries. Hi guys, welcome to the first demo. Just a couple of things to set expectations before I start doing these demos. I am conscious of the fact that you may feel when you're going through these demos with me that I'm sort of skimming the surface and not going into enough detail, and if it feels like that, then you're probably right for a number of reasons. Firstly, because Python dictionaries are huge. The topic area is huge. We don't have to just be using Python dictionaries to represent records. They are very, very powerful, and they are quite complicated at a lower level of detail to be able to use effectively. We have different syntax, some of which is a legacy from Python 2 and some changes that have occurred in Python 3, so I'm trying to stay a little bit away from that as well. We also have, just to add complexity to everything, a data structure under the bonnet with dictionaries, which I haven't mentioned to you. They won't get mentioned on your course by any of your teachers, I suspect, and it's called the Python tuple or tuple, and it's a data structure that's very similar to the list. To cover that off with lists, arrays, dictionaries and tuples, guys, would just confuse yourselves, and it's not needed for your GCSE. So I'm trying to stay away from getting bogged down with the tuple data structure, which sits underneath the surface here a little bit. And secondly, guys, because the purpose of the demos really is just to give you sight of how we use a particular or very well suited Python data structure to represent record structures that you would normally see in a spreadsheet or a database table. So I'm trying to keep this very much focused on the purpose of the video. So I apologize, guys, if it feels that it's just a sort of surface skim, but of course you are welcome to explore dictionaries in your own time. You also have the Python monster book that you can look through to get a little bit more details about dictionaries as well. And you can set yourself up as a little bit of a programming hobby to learn more about dictionaries if you wish, guys. Okay, but we must just stick to the tip of the iceberg for the purposes of these demos, guys. Okay, now the other thing I'm going to do is a bit more copying and pasting than I normally do, because unlike the other code with Python dictionaries, to make them formatted properly on the coding screen takes time, and I don't want to be spending that much time formatting the actual layout of dictionaries, guys. Okay, so I'm going to be doing some copying and pasting from existing text, okay, just to save us a little bit of time with these demos. Okay, so I've set ourselves up with the first demo to establish a simple record, okay, from our table example, guys. So I'll pop that up on the screen now. So this is the original database table that we looked at earlier on in the slides, and I'm going to take Peter Smith's. All right, so this is the 28-year-old Peter Smith's record, and we're just going to use a dictionary to store the contents of a single record. Okay, so for Python dictionary, read record and vice versa. Right, so let me just pop the structure and the contents of a record onto the screen for you guys. Okay, so here we go. And you can tell straight away that it does look very similar to the Delphi example that you saw earlier on. All right, I formatted it specifically down the screen, guys, so that we can make a distinction between fields and values. I'll talk about that in a second. But first of all, let me just talk about the big picture for the syntax and what you need to remember. So the actual content of records using Python must be contained, guys, within slinky brackets or braces, to give them their technical term. Okay, so you can see that the actual values, all right, the real content for our record is contained inside a single pair of braces at each end, guys. Okay, and you can see here that our key and our value are separated by a colon. All right, so those must go in between the key and the value associated with the key. On the outside of that, of course, and it's part of the syntax for assigning to a variable name, in this case record 1, we have to have an ordinary bracket right on the outside. Okay, so in a sense the data contained within our braces is nested inside two outer brackets, which are our ordinary curved brackets, guys. Okay, so those are the two golden rules for syntax whenever you are populating a record with some content. Right, so let's look at something that we addressed a little bit earlier on with the Delphi example, and that's the idea of fields and values. Okay, so on the left here we have what you would have seen as the fields within our table, all right, or columns if it was a spreadsheet. So we had a field for the ID, the key account, first name, last name, etc., etc. And of course on the other side here we have actual values, okay, or attributes that we put inside those fields in the table, guys. Okay, so let's remember the terminology that we use with records. These are now called keys at the top. All right, so the values on the left, guys, are keys. These are our field names. We now call those keys. And the actual data associated with Peter Smith, these are called values. Now what we have is what's called a key value pair. And when I call them a pair, guys, I'm not joking, because you'll see a little bit later on that these two items, guys, or pairs of items, like the account and set to true, Peter's ID set to 10321, Peter's email, all right, of P Smith at rmail, these key and value pairs are literally joined at the hip, and being able to access one will automatically give you the value of the other. Okay, so in many respects, if you compare this with a Python list, these are what replace our index values that you saw in lists. So for example, if we were trying to do something like this with a list, then ID would have the index value of 0, okay, and key accounts would be at the index value of 1, etc., etc. But what we're doing here is we're switching out an index, sequential index value, and we're actually giving a name to those positions within our record. All right, and that means that we can access them by virtue of our key name. Okay, so if I ask Python to find last name, it will go away and quite happily find Smith, and we'll see an example of that in a second. Right, so that's the general syntax for creating a record with some actual literal data. Okay, so let me just zoom out a little bit. So let's explore how we can find the data inside our record. Well, one of the easiest ways of doing that, okay, is to just target an individual key. If I tell Python what key I'm interested in, it will find the value associated with the key value pair. So to give an example of this, if we do a print, okay, and inside the print, let's put in the name of our variable for our record, and then in square brackets, I'm going to put one of the keys. Okay, so let's put email. All right. And that's what that will do, is it will tell Python to go away and find the value which is part of the key value pair. All right, so obviously, guys, that's going to be P Smith at rmail here. Now let's just zoom in, guys. Obviously you can see that we have used square brackets. All right, please don't get confused with what's in the square brackets and index values that you saw with arrays and with Python lists, because these are not index values, guys. The square brackets just happen to be the choice made by the Python developers as part of the syntax. All right, the square brackets are not containing index values, and in fact I can show you that, because if let's get rid of the boxes, if I put in here an index value, all right, like 0 should give us ID. All right, so if I try and print that, guys, on screen, okay, it comes up with an error. Okay, because it simply doesn't recognize what that is. Okay, it's expecting a key value, guys. All right, and it doesn't recognize a key as 0. All right, so index values simply don't work. So let's pop the key back in. All right, and get rid of our spurious stuff. All right, so let's print that now. Okay, and there you go, guys. You can see straight away that we've got the other half of the key value pair. So if I want to access any individual value at any point in my record, I simply put in the key, and that gives me the value back again. Okay, let's look at something a little bit more complicated. We can use particular features. It's a number of features, guys. Okay, of records, and you can see them listed here. We could do records.items. That gives us all of the key value pairs associated with the record. Okay, values just gives us the values. All right, so out of the key value pairs, it just gives us the values. And guys, no surprises really. The opposite of that is asking Python just to give us the keys. All right, so as part of the key value pairs, we can either just get back the values or the keys, or we can get back anything, okay, or everything, which is the items. All right, so those three things, items, values, and keys, are very useful for us to be able to isolate particular data, okay, or items of data within our record. Now, one of the most useful ways to work with this, guys, is actually to choose items. All right, so if I do record.items, all right, so I'm just going to print out the raw data associated with this record. Okay, so basically I'm asking Python to print out everything as it sees it from that record. Okay, and let's have a look at this, guys. Right, now this actually does look quite horrendous for a number of reasons. Firstly, because when we're using dictionaries, we very often get this header printed out, which we don't see with other data structures. All right, you don't get a data structure like an array where you get a header at the front that says array. Okay, but you get a header with dictionaries using this particular feature. And the other thing, guys, you will notice here is that we have an opening curved bracket followed by an opening square bracket followed by another opening curved bracket followed by another closing curved bracket, and so on, so on, and so on, guys. So you've got multiple data structures contained within this view. All right, and this is one of the things which I'm trying to avoid getting too bogged down with. Okay, getting a hold of those individual items is not easy on the basis of what you're looking at on the screen. So we're going to use iteration, all right, and I'm going to show you a really useful little technique for being able to isolate the individual values within your record using iteration. Okay, so obviously if you've got a large value record, guys, you don't want to be just printing out multiple print statements asking Python to get the key value pairs back, all right, like we've just done earlier on. Right, so having got the items, what I'm now going to do, I'm just going to zoom out a little bit, guys. Okay, what I'm going to do is I'm going to say for items in, okay, and then we're going to do, let's just get rid of the print because you don't want that anymore, and I'm going to steal this line. All right, so I'm going to cut it out of there and I'm just going to pop it here. Okay, so for items contained within record1.items, all right, in other words, we're going to start drilling down a little bit without getting too bogged on the complicated data structures that sits in there. All right, so this is basically a collection style loop. All right, now what I'm going to do is I'm going to unpack the items. All right, so I'm not going to go into detail about what you're actually seeing. All right, just trust me that this is a really useful little technique. All right, so we're going to do key, comma, value. All right, so sensible variable names is the unpacked content of items. All right, then what I'm going to do is I'm going to do fprint formatting, guys. All right, so if you've not seen this before, don't worry. It's just a format, a nice printing format to print values across the screen. So we want f, and then we want two quotes, and then in our quotes I'm going to put the values in slinky braces, guys. This is a printing format. Okay, this is not to do with the slinky brackets or braces for the record data structure. Okay, so in here, guys, I want to put key. All right, and I'm going to put in here value. All right, so our variables sit in the formatting, this special print formatting, guys. Okay, so basically I'm just asking Python to print out the value of the that's been assigned to those individual variables after unpacking. Okay, so let's run that, see if we get something that's a little bit more useful. Oh, there we go, guys. Okay, so now you can see we've essentially got the key value pairs, but we've isolated them and printed them out individually. All right, so now having got a variable associated just with the key, all right, so ID, key account, all right, first name, and I've got a variable associated with the actual values, okay, so Peter Smith's personal details. Of course, now I've got those stored in variables, guys, I can do what I want with them. Okay, so one of the things I should have mentioned, guys, but I didn't, unfortunately, is the fact that, of course, in our original record structure we have different data types. So we've got an integer here, we've got a boolean here, of course we've got strings in green, and then finally an integer for age. So when we're iterating through our loop, key and value essentially are being assigned different data types for whatever a value they're being assigned with. And to show you that that's the case, and in fact the data types of each of our values in our key value pair are remaining consistent, okay, I'm just going to put an extra print statement in here just to show you this is the case. I'm going to print Not so much key, because all of our keys are string types, although of course our keys could also be different data types as well. I'm going to put in here type, okay, of, and then I'm going to put in value. Okay, so that will, this is a special Python function which will allow us to print out the type, the data type of the value that's been assigned to value. Okay, so let's run that, and I can show you that the original data types are remaining in place. Okay, so here you can see, guys, we have an integer, okay, we have a boolean, we have the strings, okay, and finally the integer, which is what we would expect for 28. Okay, so all of the original data types remain intact when we are iterating through this loop. So you can imagine how hard this would be in a language where we can only assign a given variable with a specific data type. All right, and we'd have to cater for that with lots of if statements within our iteration and to assign to specific variables, because the data type is changing as we iterate through the record structure. Okay, so Python really is, despite its quirkiness and eccentricities, really is so much easier to work with in many cases, just like this one. And of course, guys, that's one of the reasons why I've chosen this elaborate print formatting technique. You may not have seen this before, I've done it in other videos, but it does mean that actually the print statement is not dependent on my casting with different data types, okay, because this particular format in the braces here will take any data type. Okay, so I don't have to cater for using commas or using casting or an error, because I'm concatenating data types that aren't strings. Okay, so another example of how flexible, okay, and compliant Python is as a programming language. Okay, guys, so in this demo then we've covered off the basic structure of a Python dictionary that we're using as a record. We've looked at creating a structure with initial values in place, and we've looked at a way in which we can access an individual key value pair by providing Python with the key, and then Python goes away and finds the value associated with that key. And also, guys, in this latest example here, we've done some iteration using the collections iteration available to us in Python. And then we have, let me just take that out, guys, because that was a bit of an aside really. I've shown you a really nice little technique for using the record.items function in order to be able to unpack and have the individual key and the individual value being assigned to individual variables. So at that level then of course you can work with the individual data that's contained in those individual variables, guys. Okay, so you've got ultimate flexibility to do what you want with the values contained in your record at that point. Okay guys, so let's move on to the next demo. Okay guys, so here we are with demo 2. Things heat up a bit in demo 2, guys. We're taking quite a leap from the world of individual records to a table which itself contains a number of records. So before we dive in at the deep end with a more complicated demo, let's just take some takeaways from the last demo, guys. Okay, so at the expense of repeating myself, guys, it's probably worth mentioning a few of the most important things from the first demo, I think. So let me just bring up my drawing tool, guys. So what we said in the first demo, guys, is that we're using a dictionary data structure, okay, to work as a record. All right, so this is a dictionary record, if you like. And we said, guys, that just as you have with a table in a database, all of your values, okay, so in this case all of the personal information about our customers has to sit in a particular field. All right, so I know from a database perspective, guys, you know that, and that makes perfect sense. You can't have an item of data that doesn't sit somewhere that's not in a field. Okay, so an item of data in a table has to sit in an appropriate field in the table. All right, now likewise, when we are working with dictionaries and we're using those to simulate records, we have to have an item of value associated with a key. All right, so it's the same type of thing, just different terminology. All right, so if we're going to put a value of true somewhere in the table for Peter, then that has to sit in the correct column, guys. Okay, and the column is called the key account. Likewise, Peter's first name has to sit in the field associated with first names. All right, so the key value pair, guys, is saying exactly the same thing really. It's saying that every value in our record has to be associated with a key. Okay, so every value has to have or be part of a key value pair. All right, and you'll see key value pairs come into prominence a little bit more in this demo, guys. Okay, so that's the first important thing to mention. We also mentioned the fact, guys, that we have multiple data types as well, and we also talked about the fact that the actual key value pair, in other words, what constitutes our table in the database, is all the stuff that sits between slinky brackets. Okay, and in our slinky brackets, guys, of course, we have to have keys and we have to have values. All right. So I know I've laboured that a little bit, guys, but you'll see the relevancy of that a little bit later on. So in this demo, what I've done is I've actually hard-coded some extra examples of individual records. Okay, so if I just scroll down a little bit, let me zoom out and just scroll down. Okay, I've hard-coded in 2 other customers. Okay, one of whom is Janet Long, right, and the other one of whom is Craig. Now, of course, in the real world, guys, we simply wouldn't do this. Okay, nobody's going to hard code values for table records into their actual Python code. For a start, they could be out of date, and for a second reason, guys, of course, we could have hundreds of records, so it's all a little bit silly in terms of a real world program. But I'm doing this because actually it's important to show you the syntax and how we work with individual record dictionaries in a table. Okay, so what we would actually probably do if we had something of a similar requirement is we would want to read the individual records in from a database directly, or we would want to read them in from a spreadsheet directly if we could do that. The last resort really is to read them in from a text file, and I will actually be doing that in the next demo just by way of a little bit of revision as well. And the challenge in the next demo is translating the data from a Python list into a dictionary structure. Okay, so and yeah, the reason I want to do that, guys, is because actually, like I said earlier, you may well have a practical programming project which involves file handling, and then you would know how to use a Python dictionary to handle the text data if you wanted to do that. Okay, so that's all coming along in the next demo. If we've got time, guys, I might split it into another video. Actually, we'll see how we get on. Okay, so we've got 3 individual hard-coded records, okay, or dictionary records, if you like. One for Peter, one for Janet, and one for Craig. All, of course, guys, following the same structure because each of the records are of the same structure, guys, as well. Right, so let me just run this and I can show you what the program actually does. Okay, so let's just run the program. So the first thing that we get, guys, is a little bit of a printout at the top. Okay, and I will explain where that comes from in a minute. It's basically saying that using a simple key value pair, we've located the surname of Smith, which is Peter Smith's surname, guys. Okay, and the next bit here, guys, is we're actually asking the user for some input. And what I'm going to do here is I'm going to input an actual customer account number. Okay, so I'm going to cheat a little bit. So I'm actually going to do a copy and paste. So I'm going to copy, I think that's Janet's customer account number from here. Okay, and I'm just going to paste it across, guys. All right, so that just saves me making a mess with the typing errors that you know that I make on a frequent basis, guys. Okay, so we've got a valid customer number. It's an integer data type, guys. Okay, so I'm not doing any data validation. I'm just relying on the user putting in something that looks vaguely like an integer. Okay, and it says found record, and then it gives me back Janet's email address. Okay, so out of all of the records in the table, it's located the correct record, and it's gone away and it's found an individual value within our record. Okay, so let's go through the code and I will show you how each of the relevant lines and blocks of code actually work. Right, so let's pop that back and let's zoom in. Okay, so obviously, guys, you know the syntax for the records, so we'll skip past those. All right, so this bit here, this is about how we actually add a dictionary record to our dictionary table. Oh, I've forgotten to show you the declaration, haven't I? Yeah, sorry, guys. Right, so right at the top of the code, I have declared a table dictionary. Okay, so this is a table data structure which I'm going to use to contain all of our records. Okay, so our table dictionary is declared empty initially, and you can see it on the screen, guys. It's a very similar syntax to declaring an empty list. All right, so basically we're declaring a dictionary data structure, all right, which we're calling table. All right, so my variable name is table because that's actually what we're using it for. Okay, so that's the syntax that we use to declare an empty dictionary. All right, just 2 braces back to back. Okay, right, so let's scroll down a little bit then to our assignment where we are adding records to our table, guys. Okay, so we want to come back down to this point here. Right, so this is the relevant 3 lines of code. So you can tell, guys, that I've got 3 lines of code because I am individually adding our dictionary record to our table dictionary. All right, so this is the syntax, guys. All right, so let's go through the syntax bit by bit. So right in the middle here, we have data in between braces. So you remember, guys, from earlier on, it's exactly the same requirement that we had up the top here, guys. Okay, we said that content for a dictionary must comprise a key value pair, and those key value pairs must be contained within slinky brackets. So it's the same syntax that we've got here. It's just, guys, that we've got one key value and one we've got one key and one value to add to our table. Okay, so let me explain how that works. What I've done is I have chosen, and I didn't have to do this actually, I have chosen my key value pair. First of all, the key is actually the same as the customer account number from the record. And the reason I've done that is I thought if we're going to ask the user to search for a customer, then the user is going to want to put in the customer account number. All right, and we actually want to search on the key within our table dictionary. So it would make great sense to use the individual customer account number as the key that identifies the record as well within our table. Okay, so what we've done is for our table dictionary, we have used the update function, guys. Okay, so that's the way that we add items or values to a dictionary. We don't have append with dictionaries, we just have update. Okay, so that's the equivalent of a sort of list.append. Right, because our table is empty, we're simply adding a dictionary record to our dictionary table, if you like. And here is the key. All right, so I've chosen the customer account number as my key, and here's the value that's associated with that key. It just so happens that the value is a record in its own right. Okay, so it's a record dictionary, if you like, that we're adding to our table dictionary. Okay, so the rest of this, guys, follows exactly the same syntax, and of course if we scroll up you can see that 997658 is actually the unique customer ID for Janet, I think. So let's just pop up and make sure. Yeah, there it is. Okay, so this particular value appears within the record itself, but I've sort of plucked that out and copied it so that I can use it as the key that identifies the record in the table as well. Okay, so as I said, guys, I could have simply called that Janet Long to identify the record if I'd wanted to. Okay, but I've chosen to do it that way around. Okay, so let's pop back down again. Okay, so we've done that bit. So we've added our 3 records to our table dictionary. Now this bit here, guys, I just wanted to show you an option that's available for being able to pull out an individual record within our dictionary table. Okay, and then essentially what we're doing is we're using unpack. Now the important part here is that in order to be able to find a particular record dictionary within our table dictionary, all right, what we do is we use this syntax here, guys. Okay, so we take the name of our table, which is obviously just table, and then with square brackets we put in the key. Okay, so out of the key value pair, all right, there's the key value pair there, guys. I'm just providing Python with the key, and of course, as you know, guys, if you provide Python with the key, it knows what the key value pair is, so it goes away and finds the value. Of course, the value is actually a record in its own right. Okay, so once we've got the record, once we've got the value back from the key value pair, we can actually unpack our record, which is what's happening here. Okay, so this is an unpack. All right, and this is just formatting, guys. Okay, so that this doesn't appear off the end of the recording screen. I've just used the / character, all right, so that I can use new lines, all right, on the screen. All right, so Python will allow you to do that if you use the / character to split a single line across numerous lines in your code. All right, so it's not a problem being able to do that. So the syntax to be able to pull out an individual value within our record, guys, once again, is to simply do exactly the same as we've done here. Okay, we use the square brackets, we use the name of the structure, which is record in this case. Okay, we provide Python with the key out of the key value pair, and then Python goes away and it finds the value associated with ID. All right, so unpacking then allows me to have all of those individual values in the record associated with individual variables. Okay, and you've seen unpack being done on many occasions, guys. The key thing I think to take away from this is the syntax that we use for being able to find an individual dictionary or an individual record inside our table dictionary, if you like. Okay, and we're using the key out of the key value pair on both occasions, guys, to be able to do that. Okay, now guys, of course it's slightly different coloring because our key is an integer data type here, and our key for individual records, of course, is a string data type. Right, so that's just to emphasize the fact that with key value pairs, both your value and your key can be different data types. Right, this is how flexible Python is when you're using dictionaries. All right, quite cool, really. All right, so having done that, guys, this is where that first print statement comes from in the output. Okay, so where it said here, using a simple key value pair, last name is Smith. So that's the result of these lines of code here. All right, so what I've basically done is I've got last name. All right, and last name, guys, comes from here. All right, so Python's unpacked the value associated with the key last name. It's assigned that to the variable called last name here, which of course is Smith. And I've been a bit cheeky here, because I know that this happens to be a string data type. All right, I've just used basic concatenation in my print formatting. All right, if of course I decided to pluck out the age, which is an integer data type, I would have had to have used casting in my print function there. Okay, so I've just sort of taken advantage of my in-depth knowledge of my own code, unfortunately. Right, so the next bit, guys, this is a little bit more detailed, and this bit here is the code associated with asking the user to provide us with the key, which is the customer account number, and then what we do is we go to the table. All right, we go to our table dictionary, we ask Python to pull out the key, all right, which is basically the customer account number that we've been given, and then once we've got the key, of course we've got the value, and the value is an individual record in our table. Okay, very similar to what we did earlier with the clunkier looking code. So let's go through this block of code in line by line, guys. Okay, so basically search item is the variable that's been provided by the user, so that should be an integer customer account number, and you can see here, guys, I've cast it to an integer data type. Okay, so as I said earlier, I've not done any input validation here, guys, so I'm relying on a sensible input. So it says here, if search item in table. Now this is the easiest way to find whether a key exists within a dictionary, all right, or in our case, whether a record exists within our table. All right, now because each of the records has a unique key, which essentially is the customer account number, I can simply ask Python to say, does the account number that the user's given us exist within our table dictionary? All right, and that's the very simple syntax, guys. You've seen the in operator used lots of times before in the classroom and in the videos as well. If the input provided by the user is a key that exists within our table dictionary, then we've got some work to do. Okay, if not, guys, let me just page down to tell you what happens if it's not found. We simply print out here a little message saying customer ID not found. Okay, so if we do have a positive evaluation, all right, of our condition here, what we need to do is we need to get hold of the individual record in the table, and the syntax for doing that is here. Okay, and we're using items again, guys, which I said in the last demo is probably the best function to use to get access to our individual values. All right, so we said record is assigned with the items of our particular record in the table. So we ask Python to find the record in the table, and we use the same syntax, guys, there. Can you see? It's the name of the dictionary, which is table in our case, the name of the key, which has been provided to us by the user, and once we've got the key value, Python can then go away and find the key value pairs, all right, and then express that as a set of items, if you like. All right, now once we've got the items, all right, we can then do a little bit of unpacking. All right, so here's record, all right, which is our individual record in our table dictionary, and then we can unpack that and we can assign to an individual variable all of the values contained within that record, guys. Okay, so just as a reminder, if I just pop up, all right, to an individual record, all right, so we have, of course, guys, all right, we've got the ID, the key account, first name, last name, email, phone, and age, and those are the reflected in the variable names that I've got here, guys. Okay, so I've got ID, account number, first name, last name, all unpacked from record. Okay, Now notice guys that record, okay, by virtue of items, you might remember this from the last demo, items gives us both the key and the value. It gives us the key value pair. Alright, so what I've actually got assigned to each of these variables actually is the key value pair. Alright, so I need to do, if I want access to the individual key and the individual value that sits within the record, I need to unpack it once more. Alright, so you can see that here guys, you saw that as well in the last demo. All I've done is I've said, this is just an example of one of the particular values assigned to one of my variables, and I've chosen email guys, okay? So as an example, I've said, right, key and value, okay, are the variables that result from unpacking email. In email, I've got two values. I've got the actual key and I've got the data value associated with that key, okay? So if I unpack it, and I've conveniently called them key and value, all right, and I've just printed them out on the screen guys, okay? Now again, I'm taking advantage because I happen to know that both the key and the value for email are both string types, all right? So I've just used a basic concatenation. Now for you guys, if you're using something similar for a programming project guys, or a practical programming assignment, once, like I said in the previous demo, once you've drilled down and you've actually got hold of the individual key and the individual value in the key value pair, then you can do what you want. So you can do string handling, you can manipulate the strings, you can do slicing, you can do whatever you want. Okay, it's just a question of being able to drill down and get hold of those individual values in your record, okay, using the correct syntax guys, all right, and the correct approach. And this is the one of the approaches that you can use, okay? So this is the key bit here, okay, to drill down into a record. Okay, find the record first using this syntax, okay, unpack, so you've got the key value pair, right, for a given record, and then once you've got the key value pair, you can unpack a second time to get individual assignments to variables for the individual key and of course for its individual value as well. And then the sky's the limit, because you can do whatever you want to with the values associated with those individual variables, okay? So basically guys, that is how this works. All right, now there's a lot to take on there, all right, because I did say right at the beginning of the demos guys that dictionaries are different and they can be quite complicated. So pause the video guys, go back through it, study it if you want to. As I said, I'll give you the code as a text file in the appropriate folder on Schoology guys, along with the videos as well. Okay, what I am going to do guys, I think, is to wrap this one up, because I have a feeling that we've hit the hour mark with this video, and I'm not surprised really, because dictionaries take a while to explain as something radically new for you, and a different way of doing things as well. So I will carry across the third demo into the next video. Join me if you wish to. In that video, the single demo that we will be doing will be looking at reading in text data from a delimited data file, and then working with that data to read it into dictionaries data structures for both records and a table guys as well. Okay, so I may see you in that video. See you soon.